Hey. So today, Unit 5, Lesson 3, we are talking about word problems with systems of equations. So you'll notice there's this large sort of bank of vocabulary words. And we talked about these in MSM2 as well. Words that typically mean a certain operation. So things like altogether, both, combined, well, those mean to add. Subtract, things like take away, less, left, how many more? Multiplication, times, rate, doubling, tripling, division, out of, quotient of, or taking half, third, or quarter. So you can always refer back to this table as you're working on this lesson. There are certain things that are not 100% of the time. The word is typically means equal. Like I can force an equation to not mean equal by a funky type of wording, but most of the time the word is will tell you where the equal signs goes. Translate the following algebraic expressions. The sum, so sum tells us it's addition, of a number and tells us where the plus goes, 8. So a number, you can pick any letter that you want, and 8. You could even pick, X and 8. But the word and tells us where the operation goes. So once you've figured out what the operation is, look for the word and. That's usually where you insert it. Product. So product means multiplication. A number and 4. Well, the and tells us where to put the multiplication. So we would put a number and 4. Now that's not the best way to write it. Algebraically, we would typically write 4n or 4x. Half of a number, so half of a number increased by 5. So increase would be plus, increased by 5. But how do we find half of a number? If we look back up, half was one of our words that told us it was going to be division. So we could do something like half of a number, x divided by 2 plus 5. We could do something like, let's push that down at the bottom. We could do something like x divided by 2 plus 5, though you typically would not see that division symbol, right, because it's algebra. You can also do half as the decimal 0.5 times x, and then increased by 5. So sometimes there is more than one correct answer, but we're looking for the best answer. So on the first one, the sum, either of those is fine. But you'll notice that I put the variable first, which is the better answer than putting the 8 first. 4n is the better answer than n dot 4. This answer is fine and this answer is fine. It really kind of depends what you're working with. Like if you were working with money, a decimal would make more sense than, say, the x over 2. But those are both acceptable. You don't typically see the line with the 2 dots anymore. The sum of two numbers is 92. So first I noticed the word is. So that's where my equal sign would go. The sum of two numbers. So sum meant addition. Two numbers. So I can pick what letters I want. So I might pick x plus y is or equals 92. Sum because it's addition. X and y means there's two numbers. Their difference is 20. Now you can choose, because you're choosing the letters, which order they go in. It's just going to determine which is the bigger number and which is the smaller number when you subtract them. So their difference, x minus 2, is equals 20. Find the numbers. So this is a system of equations. I want two numbers that have a sum of 92 but a difference of 20. Now you could guess and check for a while, I'm sure, with a table. It's a little faster to do it with the system of equations. So I might take, for example, this one and rewrite it. So x plus y equals 92. I might subtract the y from both sides and get x equals 92 minus y. Okay, so anywhere that I see the x in the second equation, I can put the 92 minus y in its place. So 92 minus y, and then minus y equals 20. I just substituted in place of this x everything that x was worth. So 92 minus y. That could be 92 minus 2y, because it's minus 1y, which would combine for minus 2y, equals 20. That's a two-step equation. So I want to solve that two-step equation. I'm going to subtract 92 from both sides. Negative 2y equals negative 72. Divide both sides by negative 2. And I'm going to get y equals 36. Now that, again, system of equations, that's only the first part of my answer. I still need the rest of the solution. So I'm going to go back up. I'll take the x plus y equals 90. I like addition better than subtraction. And I'm going to substitute where I found that y equaled 36. X plus 36 equals 90. Subtract 36 from both sides and find that x has to be 50, right? 50, what am I doing? 90, take away 36. Oh, geez, I wrote 90 and it's 92. I'm thinking, what did I do? 92 minus 36 is 56. There we go. Something was not adding up right. So I think the solution is 56, 36. The two numbers are 56 and 36. But what I can do is I can double check. Does 56 plus 36 equal 92? Sure does. Does 56 take away 36 equal 20? Sure does. On to the back. In order to solve some systems of equations, you will have to wait for the focus. It will be necessary to know some geometric relationships, such as the sum of the angle measures in a triangle is 180. So if you were to add up the three angles in a triangle, they should equal 180. Complementary angles are two angles whose sum is 90 degrees or creates a right angle. So complementary, that's a vocabulary word that you need to have in your back pocket. So something like x plus y equals 90 if it's two angles that create a right angle. Supplementary angles are two angles whose sum is 190 or creates a straight line. So something like x plus y equals 180. That is specific when you see supplementary. And right angles have one right angle and two right triangles. So if you have a right triangle, you know one of them is always going to be 90. So you would have something like 90 plus x plus y equals, and all three angles in a triangle have to add up to 180. So you might have for that one equals 180. In triangle ABC, the measure of angle B and angle C are the same. And angle A is twice the measure of angle B. Find the measure of each angle. So the first thing we know is this is a triangle. So we know it's got to add up to 180. And we know we've got two that are the same. So if we had just some random triangle, no idea if it's actually going to look like this or not, but I know two of them are the same, like this could be angle B and this could be angle C, it might be worth x degrees and x degrees, and then there's some other one over here that we don't know. So we could have x plus y equals 180. This is just a random drawing that goes with the measure of angle B and angle C are the same. So I made angle B and angle C the same letter. Angle A is twice the measure of angle B. Angle A is, there's my equal sign. So I use the letter Y to stand for angle A. So I might say Y is equals twice the measure of angle B, 2x. So now I have a system of equations. I can substitute anywhere there's a y in the first equation, I can put 2x in its place. So I would have x plus 2x equals 180. 4x equals 180. Divide both sides by 4. X equals 45 degrees. Okay, so that means this one's 45 degrees and this one's 45 degrees. And then I know that one of the angles was twice the measure of A. So if that's the case, in order to find y, it's got to be worth 2 times whatever I found x was, which was 45. So y has to equal 90 degrees. Now, that's just pure luck on my part that I happen to draw something that remotely looks like a 90-degree angle. But what you've got is a 45, 45, 90. That adds up to 180. And also, angle B at 45 is twice angle A. If you double angle B at 45, you get angle A, which is 90 degrees. All right. Two angles are supplementary. So the first thing I would need to do is say, okay, supplementary was a vocabulary word. I might need to look it up on the notes. Supplementary means that the two angles have a sum of 180. One of the angles is 34 degrees more than the other angle. One of the angles, so pick any letter that you want, is 34 degrees more than the other angle. Like, no one's going to care what letters you pick as long as you use those same letters in any other equation for this system. Now, it looks like they didn't give you anything else, but it did say that the two angles were supplementary, meaning the two angles, the M and the N, had to add up to 180. That's your other equation. So the two angles being supplementary is this one, and then one angle is 34 more than the other angle is the first one that I wrote directly under it. So now, anywhere that I see 34 plus N, it's worth M. I can put it in place of the letter M in the second one. So instead of the M, I'm going to put the 34 plus N, then plus N equals 180. So that's 34 plus 2N. And I'm going to subtract the 34 from both sides. 2N equals 146. And divide both sides by 2, N equals 73. Now we did say we were looking for a pair of angles that had to be supplementary. So if one of them is 73, I still need the other one that adds up to 180. So M plus 73 has to add up to 180. Take away the 73 from both sides. I get M equals 107, and that would give me my pair of angles. Now, in the one above, I did label them with the degrees symbol, which is like my units. Down here, I don't really have any units yet, right? So I could say 73 degrees and 107 degrees because I just didn't happen to label them next to the M and the M, are the two angles. All right, so don't forget, supplementary can come up, right triangles can come up, complementary can come up, and you can always look those up in the notes.